Okay, Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good day everyone. Okay, so today is our asynchronous lecture for week 7, right? So week 7 means that this is going to be our last asynchronous lecture before you go for your mid-semester break next week for 1 week only. Okay, so for today we are going to continue with still in chapter 3, part 1 notes. Alright, okay, so the subtopic that we are going to cover for today is about the derivative of trigonometric functions. Okay, and I'm planning to discuss not only about derivative of trigonometric functions, but there will be another 2 subtopics, which is about the chain rule and also implicit differentiation. So means like maybe the video may have up to 4 or 5 parts lah. Okay, so for this derivative of trigonometric functions, okay, everybody, okay, by the way, okay, everybody knows what is trigonometric functions. I'm sure since you all daripada bila form 3, form 4, form 5, okay, you have discussed about this trigonometric kan. Dalam bahasa Melayu pun kita panggil trigonometric functions. Okay, it's all coming from triangular ni kan. Oops, cantik pula saya lukis ni, macam tu. Okay, where we have an angle, so yang kita panggil ni kita panggil hypotenuse. Okay, so we have sine. What does it mean by sine? Okay, let's say we have A here, B and C. Okay, sine theta. Okay, we have a sine theta if A setentang over hypotenuse, right? Sine theta is equals to A over C. Cos theta is equals to B over C, and we have tangent theta, right? Okay, and then 1 over sine. 1 over sine sama dengan apa? Okay, one is all revision to all of you. 1 over sine theta is cosecant theta. Okay, and okay, this is B over C. Okay, cos theta is B over C, and then we have tangent theta. Okay, A setentang over bersebelahan, right? A over B, and then we have 1 over sine theta is cosecant theta. Cos theta, 1 over cos theta is secant theta, and 1 over tangent theta is cotangent theta. Just a quick recap on that. What is the trigonometric function? Okay, so here what we are going to discuss is about, not about, I remember masa I sekolah menengah dulu, we have a lot of pembuktian trigonometry. Tak sure sekarang ni ada lagi tak? Okay, but now we're not going to prove the trigonometric identities and all, but now we are going to discuss about the derivative of the trigonometric function, meaning that differentiate sine dapat apa, differentiate cos dapat apa, differentiate tangent dapat apa, and so on and so forth. Alright, so for the first derivative of y equals to sine x. Yes, I know we have formulas, but again, I'm going to show to you how actually by using the first definition of the derivative that we have discussed earlier in this chapter, okay, we prove that the derivative of sine x is equals to cos x. I know this is not really important because you can just always remember the derivative of the function, but in case lah kalau you all tak ingat, okay, then you may derive like this. I'm not sure how many of you will do that. But out of this also, actually, I'm going to discuss with you this, okay, which is another important things that you need to know. Okay, so what does it mean by this? Okay, let's have a look on this first. Okay, so from the definition of derivative that we have discussed earlier, okay, this part should be familiar to all of you now. Okay, limit fx plus h minus with fx over h as h approaching 0. Okay, so for this case, our function fx, okay, our function fx here is sine x. So that's why here fx plus h, of course, is equals to sine x plus h. Alright, so we have this sin x plus h, okay, minus sin x over h. Alright, okay, and then from here, okay, how do we get this? Okay, how do we get this? Sin x plus h, okay, is equals to sin x cos h plus cos h sin x. Anyone can recall back how do we get this? Okay, this is back to what you have learned before in algebra and trigonometry. Okay, where we have sin a plus b. Okay, we use the trigonometric identity, sin a cos b plus with cos a sin b. Okay, I'm not going to discuss more on this. Okay, we have the identity that you have proved before long time ago. Okay, so sin x cos h plus cos h sin x, okay, is equals to sin x plus h here minus with sin x over h. And then as you can see, we have a common term here. We have sin x here, we have sin x here. Okay, so and we also have sin x here. Okay, so what we do here, okay, I separate this into two terms. Okay, into two terms. Okay, first term I combine sin x cos h with sin x. Okay, not this one and this one, but instead this one and this one for the first term here. Okay, so I factor out sin x. So I have cos x minus 1 over h, and I left this term alone. Okay, alone, plus with sin h, ni saya terbalikkan je, sin h plus with cos x over h. Alright, and then from here we're using the law of limits. This is revision from chapter 2. Okay, using law of limit, we can separate this into a multiplication of two functions. Okay, a multiplication of two functions. So we have limit sin s as h approaches 0 and limit h approaches 0 cos h minus 1 over h. Okay, plus with limit sin h over h as h approaching 0 times with limit cos x as h approaching 0. Okay, so from here we have limit sin x times with, okay, how do we get this? Okay, how do we get this? Because, okay, we have actually an identity or a formula, okay, saying that limit cos h minus 1 over h as h approaches 0 is equals to 0. Okay, this thing equals to 0. And another term we have limit sin h over h as h approaching 0. This term is equals to 1. Good. So that's why kat sini saya tulis darab dengan kosong tambah 1 darab limit cos x. Okay, so this thing, okay, limit sin x as h approaching 0 times with 0, definitely this term will become 0 because sin x tak ada kaitan pun. Tapi kalau limit sin x as h approaching 0, okay, this thing is a constant kan. Okay, it doesn't depends. H and x doesn't depend on each other, so this one is still sin x lah. So sin x times 0, you will get 0, whereas this one you have 1 times with limit h approaching 0 cos x. See, this is h approaching 0, so it's x here is independent of h. It doesn't depends on x h. So bukan kata kita substitute x ni sama dengan kosong, because this is h not x. Okay, so that's why it's independent, so the answer is still remain as cos x. So that's why we get the answer equals to cos x. Okay, so out of this derivation of the derivation for the derivative of sin x, actually we come out with two formulas for limits of trigonometry, where we have limit of cos theta minus 1 over theta as theta approaching 0 is equals to 0, And another one is limit sine theta over theta as theta approaching 0 is equals to 1. Okay, so this is actually limit of trigonometric functions, where kalau sepatutnya limit ni kita belajar dalam chapter 2 lah, right? Okay, limits and continuity, but somehow we bring forward here in chapter 3 because it is directly related with the derivative of trigonometric functions. Okay, so now let's going to discuss these two examples. Okay, in the next slide lah, saya dah tak ada space kat sini. Okay, so for the example A here, okay, you see limit as x approaching 0 for sine x over 4x. If you directly differentiate here, okay, what you will get, sine 0 is 0 kan. Okay, siapa yang confuse sine 0 dapat berapa Okay, okay lah, saya bagi chance kat you all, tekan je calculator tu. Okay, sine 0 is 0 and over 4x, 4 times 0 definitely 0. So you meaning that you have to do something with this function. Okay, so you have to do something with this function. Maksudnya kat sini, what you can do, you may apply this formula. Okay, cos theta minus 1 over theta as theta approaching 0 is equals to 0, and limit sin theta over theta as theta approaching 0 is 1. So what do you think? The first theorem or the second, the first formula or the second formula we're going to use? Alright, kalau tengok-tengok ni sin, so definitely we're going to use the first, the second formula lah. Alright, so we have the formula for this, meaning that, what does it mean by this? This means sin theta over theta. Kalau kat sini theta, maknanya dia kena theta, sama kat sini. Dia kena sama. Kalau kat sini sin 3 theta, maknanya kalau theta saja, no, you can't say this is equals to 1. Okay, limit theta approaching 0, sin 3 theta over theta, no, you can't say this is equals to 1. But maksudnya kat sini dia kena ada apa kat sini? Dia kena ada 3 juga. Alright, should have 3 as well. But if we have 3 here, we can't simply add 3 here. Okay, we can't simply add 3 here because it's going to change the function. So what we got to do is we are to introduce 3 over 3. Nampak tak? Sebab 3 per 3, does it going to change the function? No, because 3 over 3 is equals to 1. Kita darabkan dengan 3 per 3. So with this case, we have limit theta approaching 0, 3 times with sine 3 theta over 3 theta. Nampak tak? And then from here, we know 3 is independent of theta. Then you may bring out 3. So we have limit theta approaching 0, sine 3 theta over 3 theta. There you go. Now can we say this thing equals to 1? Definitely yes. So this answer is equals to 3. Okay, so same case here. Okay, same case here. So what does it mean? What does it mean by here? 4 here, does it depends on theta, on x? Sorry, now we have x instead of theta, sama je lah. Okay, so since it is independent of x, 4 tu is just a constant, you may bring out 4. Okay, maknanya kita letak 1/4 limit x approaching 0. Okay, limit sin 7x over x. So kalau siapa yang faham example yang saya discuss yang ni, I'm sure you understand what I mean by here, or how to proceed with this. So meaning that, yang ni, what number should we add in? We are going to multiply with what? Okay, tak ada kat sini, kita letaklah, tak ada space kat sini, kita darab kat sini. Kita nak darab dengan apa? 7x, means that we have to manipulate this function, so that is going to be 7x over 7x. Okay, so we are going to have 7 over 7. Kan? Simple kan? Okay, multiply with 7 over 7. So from here, maknanya, oops. Okay, so from here, which 7 is important to us? The upper 7 or the lower 7? Yang mana yang penting? Of course, the lower 7, kan? The lower 7 is because we want to pair with this 7, sin 7x. So, the upper 7 you may bring out. Okay, you may bring it out. So you have 7 over 4 limit x approaching 0 sin 7x over 7 ni darab lah dengan yang ni. Sebab it is nothing to do with the trigo here. So we have 7x. So nampak tak kat sini? Now this term turn out to be 1. So the answer here is equals to 7 over 4. Clear everyone? Okay, so we're done with A. Now we're going to proceed with B. Okay, for example B here, we have limit x approaching 0, x times with cotangent x. Apa itu cotangent? Cotangent x. Okay, so kalau kelas synchronous ni mesti ada yang dah jawab kan. So yang ni saya tanya, saya jawab sendiri. So cotangent x is 1 over tangent x. Tangent ni apa pula? Okay, what is tangent x? Tangent is sine over x, right? So 1 over sine x over cos x. So in this case, maksudnya cotangent x kat sini is equals to, okay, limit x approaching 0, x cos x over tangent x. Okay, x cos x over, tangent pula. Over apa ni kat sini? Over sin x. Okay, x cos x over sin x. Okay, so from here, kita try to direct substitute dulu. Okay, direct substitute x with x, substitute x approach with 0. So we have 0 times with cos 0. Cos 0 ni tak sure, tekanlah calculator tu saya bagi. Okay, cos 0 is equals to 1. And that, so maknanya sin 0 times 0, 0 times 1. 0 times 1 sin x. Sin x is 0. Okay, kalau you tak ingat sebenarnya, saya tahulah you ingat. Kalau you tak ingat what is sin x, cos x, sebenarnya awak ingat tak graph sin dengan cos macam mana? If you remember, graph sin is like this. Graph cos terbalik kan? Okay, graph cos dia macam ni. Alright, so from here, maknanya kita boleh tengok lah ni sin x, yang ni cos x. So maknanya sin 0 kat sini kosong. Kat sini berapa? Kat sini pi, kat sini 2 pi. So you see here 0, 0, 0. Yang ni 1, yang ni 1. Tak tahulah ingat ke tak. Kalau tak, this is another option lah. Maknanya kalau you tak ingat, you lukis graph ni, you're able to figure out what is sin x, cos x, kosong ke 1. Cos kosong maknanya is 1. Okay, this is 0, this is pi over 2, this is pi, this is 2 pi. Ni 3 pi over 2. Okay, so maknanya kat sini kita akan dapat 0 over 0. So for 0 over 0 here, meaning that we have to do something. Kan? So we have here limit x approaching 0, x cos x over sin x. I'm giving hint to you here where you may use this theorem again. So which one? First one or second one? Okay, kalau nak guna yang ni macam ada harapan. Tapi this is cos theta minus 1 over theta. Okay, where the second one is sin theta over theta. So which one is easier for us to use? Okay, kalau yang ni minus 1 ni maksudnya you have to manipulate this function so that you can get something out of it over minus 1. Macam tak ada harapan je nak letak minus 1 kat sini kan. Alright, so for me, I think we may use again the second formula here. So macam mana nak guna the second formula here? Okay, to use the second formula here, meaning that you have to, ni, kita ada ni, sin theta over theta. But we have here only sin x. So, maknanya kat sini, kita kena manipulate this. Kita dapat jadikan dia sin x, apa? Over x. Senang je. Okay, over x. But, kita tahu sin x tak boleh nak over x saja because it's going to change the formula. So, darablah dengan x kat depan. Or, because x over x here will equals to 1. And then here, apply law of limits. Law of limits kan dia kata multiplication of functions is equals to multiplication of two function for limit, maknanya dia sama dengan first function, limit of first function multiply with limit second function. So you can do that. So maknanya kat sini kita akan ada limit x, okay, darab, so kita boleh pecahkan ya, limit x darab dengan limit cos x as x approaching 0, saya pecahkan satu-satu, over, okay, limit, okay, sekarang ni we have x sin x over x, so we can pecahkan here, limit x, okay, as x approaching 0, and then we have limit sin x over x as x approaching 0. So you see here, so here this thing definitely akan jadi 1, and this thing limit cos x as x approaching 0 is equals to cos x is 1. Betul? Okay, cos x is 1. Tengok ni. Ni. Yang ni. Cos x is 1. So here we have, kalau you ganti, of course you get 0 over 0. Tapi tengok betul-betul, this is actually limit x over x. Tadi saya pecahkan kan? Sebenarnya tak payah pecahkan, lagi senang untuk you nampak. Okay. So this is actually limit x over x as x approaching 0. So x over x maksudnya tak boleh nak tu. Okay. Is equals to 1. So limit as x approaching 0, limit 1 as x approaching 0 is 1. Alright. So with this is the answer. Okay. We have not kita tak ada chance untuk guna this theorem or this formula, but it's fine. I think you're going to see this in your assignment questions later. Assignment for chapter 3. Alright, so that's all.